Good morning, students. Today we are going to discuss about the laser. So laser is a light amplification stimulated emission of radiations. So these are the content we are going to discuss. Laser characteristics. After that, population inversion. Another types of laser. Three types is there: solid state, gas, and semiconductor laser. So we are going to discuss about only semiconductor laser, NDR only. Okay. So amplification of due to stimulated emission of radiation. This three-stage level is there. One is stimulated absorption, another one is spontaneous emission, another one is stimulated emission. So in this first stage is ground state energy level atom. With the help of incident product, it's moved to the excited state. Okay, the excited state of atom, it won't stay for the long time. It's a half-lifetime period only it stays. So after that it's coming to the lower energy state or metastable stage. Okay. So then that time during the process one energy photon is released. Okay. Then after that stimulated emission, doing emission in this higher energy state, excited state atom without any external agency. Coming to the lower energy states or metastable states. Okay, after that another one is stimulated emissions. In this stimulated emission, that excited state energy level with help of it's coming to the ground state energy levels. Okay, so after that this process goes with then population inversion. Okay, in this population inversion, normal conditions in the ground state level, more number of atoms filled. Okay. That excited states level, very less number of atoms only filled. After population inversion achieved means the higher energy states having a more number of atoms compared than lower energy states levels. Okay. The NDR laser neodymium doped polonium garnet. It's a chemical formula Y3Al5O12. It's a basically rare element. That laser will already we discussed. It's a solid state type of laser. Okay. Then in this laser energy levels, 4-level energy systems. Then it's a pulsed continuous mode process. After that principle. In this active medium, the NDR rod is optically pumped by a krypton flash tubes or xenon flash tubes. Okay. This NDR rise to the excited states level from the ground state to excited states level. During this transform, metastable to state to ground state energy state. Okay, NDR laser principle. It's an active medium. This active medium NDR laser optically pumped by the krypton flash tubes. Then NDR ions it's rise to the excited states levels. Then during this transition from metastable state to ground state energy level. In this laser beam of wavelength, so finally we are getting output 1.06 micrometer. It's an emitted laser. Construction of NDR lasers. This is based on laser rod and flash tube. In that flash tube is connected with the resistor and power supply. That laser rod it's kept in this cylindrical rod, the cavity type of rods. Okay, one is 100% reflecting mirror, another one is partially reflecting mirror. This 100% of reflecting mirror, the M1 is fully polished. That surface is very smooth. Another one M2, which partially reflecting mirror, that surface is partially coated. It's like a rough surface. Once we are switch on the power supply, that laser xenon flash tube will on. Okay, that ground state energy atom is moved to the flash tube. It's continued to the laser rod. After that, that laser process is continued. So these are the working model of NDR laser system. The ground state energy atoms it's moved to the excited states level. Okay, so first E1 and E2, then E3, then E4. It's pumped back, it's moved to the excited states level. So in this excited state energy atom, it won't stay for the long time. It's a half-life period. It's without any external agency. It comes to After that, this is external atoms. Excited state energy level atom which come from to the metastable energy system. This metastable energy system, after that it's a continuous process. Again, it's a process is continuously. After that, finally we are getting output of wavelength laser 1.06 micrometers. So this is the spontaneous transition from E2 to E1. The emitting photon energy, finally we are getting these values. So this is the chain reaction. Okay. After that, this is the photons generated from the fork between the two mirrors. That partially reflected mirror, another one fully reflected mirror, play the major roles. Okay, the photon number of multiplies, it's giving the more results rapidly. Then this is the NDR laser characters. So type, firstly, it's a 4-level solid state system, already we discussed. Another one is the active medium. The active medium is NDR laser, and active medium is when we are switched on the power supply, that krypton flash tube also switched on. It's continuous process, that's why we are said that active medium. The pumping method, optical pumping is employed for the pumping action. We are already discussed in the basic explanation, optical pumping and pumping action also. Okay, pumping action shows importantly xenon or krypton flash tube used for the pumping source materials. The optical resonator, two ends of LDR laser rod is polished. One is actually silver, another one is fully coated. One is partially coated, another one is fully coated mirror. Okay, silver, other partially coated we have discussed in the construction diagrams. Okay, power output. The power output is approximately 70 watt power supply we are using. Nature of output, the nature of output is the pulsed or continuous beam of light from the lasers. The wavelength of output, finally we are getting 1.06 micrometer infrared uses. So these are the we are discussed in that partially mirror and fully partial mirror in the construction of NDR laser. This is like fully coated mirror, and this one is partially coated mirror. The atom reflected both stage. The pumping source is Shannon glass lamp example. This type of tube we are using. So advantages of NDR laser. These advantages, high energy output it's giving. After that, it's a very high repetition rate operations. It's much easy to achieve population universal. In this very high repetition rate operation means this crystal structure is very complicated. So that's why it's giving a very high repetition operation. Then disadvantages. The electron energy level structure, it's a complicated system structure. So that's why we can't use in the many applications purpose. These are the crystal structure. This is yttrium, this is aluminum, this is argon. In this tetrahedron coordinate with the oxygen. After that, 6 octahedron oxygen, it's coordinate with the aluminum. Another one finally yttrium, do the calculation. 8 oxygen atom, it's coordinated with the oxygen atoms. So NDR laser applications, it's a military purpose we are using. The target finder purpose we are using. And another one is medical purpose. So medical purpose we are using mainly surgery purpose. After that, skin cancer removal and tattoo removal purpose we are using. After that, the manufacturing industries purpose we are using that laser welding, laser cutting, laser